So this is the moment of decision. The loco either becomes a DCC or stays a DC. I have here an old Roco v200 direct current engine. I noticed something was wrong with this when I went to lift it off the track, and the whole top shell came off. And that weight wasn't even there. In fact, these little mounting parts had deteriorated and broken off, and this whole plate was no longer attached. And look at how brittle that is and how deteriorated, the cracking everywhere. Usually that's not a problem, except in this case, this piece actually holds the top shell of the loco on with these two screw holes. The first challenge that I have with this project is to design something for here and here and hold the cover on instead of this plate. The bonus is, in doing so, I will have eliminated this waste of space here, and this piece isn't even that heavy. This loco all by itself is heavy without this plate. I think this is going to open up all kinds of opportunities for me to make a DCC conversion with this loco, with all of the extra space I make available. This 3D design file is available to my subscribed followers. If you'd like a copy of this STL sent to you, please like this video and let me know in the comments below. Okay, so the next thought I have on my mind is how much room is there inside for a DCC decoder now? Because this particular piece of metal is gone, that had thickness to it. So I'm thinking that this particular decoder, and I'm just going to unplug the harness right now because it is a little bit wide, and I'm just going to lay that on there right now and just throw the cover on, and lo and behold, that fits. So that just opens up all kinds of new opportunities, because this little piece was just wasting way too much space. And we have our solution with the 3D printed brackets for the cover, so that that loco lid goes on there really nicely now. And I notice I just squeezed it in between those light ladders, so that's great. I do believe that these incandescent bulbs here are going to be a simple matter of just clicking a 5mm LED in its place. We'll throw these aside for the time being. And if I put 5mm LEDs in these sockets here, they're going to fit somewhat the same here, and it should have the exact same effect on the light ladders. I will have to get rid of this little copper anode connection here, and then I can put in some LEDs. Now, that being said, these diodes won't be necessary because the incandescent bulb does need them for direction changes, but it does not require diodes when you're running LEDs because they are diodes. Also, these resistors for the motor, I'm going to probably pull those out if I'm converting to DCC. And at the same token, I do believe I'm going to keep this green printed circuit, because the outer two printed circuit tracks are connected to track power left and right on both ends, which is already a very nice, neat application. I'll only have to connect my decoder up to the very same solder joints for red and black. Here, if I disconnect these resistors, I'll connect my orange and gray to these two connectors. And then it's just a simple matter of running a common wire from the positives of these two LEDs, put a white on the front and a yellow on the back of the cathodes of the negatives of the LEDs and run them to the decoder, and voila, I'm done like that. Seems to be a very simple wiring job, and I can contain that particular decoder right in the top of this. In fact, with these diodes gone, I'll probably elect to put the decoder just over the hump of the motor a bit so that it even clears this the cover of the loco even better. So I do believe I have a DCC conversion well planned out. Now I just want to figure out if this damn motor is popping and pulling too many amps. So I'm going to get ready to do that test on this motor's amperage draw. Okay, here we are with I've got some 12 volt leads here. One of them is going through my ammeter, and it doesn't matter which way around I connect them, but I will be able to get DC voltage straight into the motor and see on the screen how much amperage draw this motor is pulling at, well, almost full throttle. So let's go. And this is after the resistors on the motor side. Alright, we peaked at about 0.67 as I connected. 0.75 was the highest I saw so far. We're running at about 0.3, 0.32. Yeah, again, I'm going for peak. 0.76. The peak volt, or the peak amperage, is actually the issue. So I'm not seeing any numbers higher than 0.7 to 0.76 here on the connection. So I'm happy with that. Not that we're ever going to crank it up to full blast right out of the gate, but our decoders typically operate under 1 amp and will peak at 1.25, maybe as high as 1.5, but you definitely don't want to go over that, and this is clearly not even reaching 1, so I'm happy with that as well. I think we're going to go ahead and convert this thing to DCC. So this is the moment of decision. The loco either becomes a DCC or stays a DC. At this point, I can just snap in the bulbs, put on the cover, and we're good to go. But alas, we're here to rip these things apart and put decoders in them. So, point of no return, here we go. We're just going to grab these little Zener diodes. Let me get a better tool. We're going to lift these little Zener diodes out of here. First things first, and I'm going to loosen that end up. And same on the other side. I'm actually going to save these because Zener diodes are awfully handy. So there we go. And that's one down. Okay, so that has isolated the bulbs from the power gonzo. And now these resistors, same story. They've got to come out as well. I don't want to melt anything now because these particular power pads, contacts which go down to the motor, they are still highly critical. Let me just get this thing. Come on, there we go. We're going to be using those, so we don't want to mess those up, right? And there we go. And this resistor is going to be easier. Whoop! Come on, be good. And come on. 2 points of contact, always a pain. Okay, so I'm going to clean up these little globs a bit. Yeah, so what we've got now is nice contacts to the motor. We've got no more contacts to lights. We've got no more resistors. We've got no more diodes. We have got ourselves a squeaky clean board. However, I'm not taking it out, as I said before, because I like the fact that I've got these outer contacts for the axle, or for the wheel pickups. I've got the motor contacts here. I've got the lights on top of here. It's, for all intents and purposes, the entire mechanism can be removed with just these two screws and this plate of course, unsoldering the track pickups, but it's going to be a decoder platform. Liking it already. Okay. One little test we should do before we go any further, because this could be a deal breaker, is continuity test. Now, these are my two motor brushes here, which always have a little bit of impedance across them because of the motor windings and such. But what we do want to make sure is that the contacts don't make any frame contact whatsoever. So I'm going to the axles, to the wheel pickups, I'm going to the hard metal shell. Nothing on that side. Going to the same on this side now. Nothing from the wheel pickups. Nothing there. Nothing from the shell. Motor housing. No, I'm not getting anything except across the brushes themselves, which is okay. So happy with that. You'll find that there are motors out there where the contact brushes have got one of them that is continuous with the metal frame of the loco. If that's the case, that's a no-go with a decoder until you isolate it, and that could be a complicated process, or it could be something simple. But I'm happy now that we have a safe chassis to install a decoder on, and we're going to go into that right away. All right, we're going to start connecting some power here. So first thing I'm going to go for, I've put some shrink tubing here, not shrunk, on the top of the engine to give me an idea of front and back. So this is going to be my right hand side, this is my left hand side, and this is going to be the front, because it's kind of ambiguous, right? Actually, in fact, the only thing to tell you the front and back of these locos is the number 1 and the number 2. So I'm just going to put that 1 to the left, this is right, that's left. So my motor orange and my track red is on my right, my motor gray and track black is on my left. So I'm going to go ahead and shove this motor gray through here right now. I put those little conduits per se in there just to keep wires from getting pinched in the wrong place, because that can happen in these very small installations. So we're just gonna give that a little dot of solder there. And we'll start with the left gray motor. Come on. Oh, that turned down my soldering iron too much. There we go. Okay, left gray. That's in place. Now, so what I want to do here is situate this now into a comfortable location. So that means I'm going to run my red to the track next, because that seems to be a great way of locating this to the shortest possible location. And we'll touch that and give that a little. Yeah, hang on a second. That's the wrong one. Ooh, almost put on the wrong one. Wouldn't that be dumb? Okay, so same blob as the track power's on right now. Liking that. And that's going to locate that beautifully here. I'm going to get rid of these wires a bit, and we're going to set that black track power down now on the left. So it's now left track power. Right? So let's get that position. We don't want to melt everything else, but here goes. So, well, come on, be good now. Of course, I'm 60 years old, so I'm twitching a bit. I have too much caffeine in the course of the day. Yeah, come on, that's it. And that's nice. Now let's take that orange for the motor right, and I'm going to send that through my little funky conduit here. And I hope I didn't screw up with my cable length, because I'm an aggressive cable trimmer. Not too worried about making the cables too short in this case, because this is a decoder that can be unplugged from a very common chassis. So, a very common plug. So here we go. I think that's pretty nice. We're gonna get this soldered onto this blob over here. I didn't do the blob, somebody else did the blob, but it should be good. I think that went down good. So what we got so far is better. Motor orange is right, going through my right red conduit. Motor left is gray, going through my black conduit. Track power black on the left, track power red on the right. You'll notice that my track power is still connected from the front trucks, and along that very same outer printed circuit there's also the track power left and track power right for over here. I've removed the bulbs and resistors and diodes that'll make that continuous with anything else, so I'm not too concerned about that either. So I'm thinking we are good except for these three lights. Notice I have cut off the purple and green leads. That's absolutely not happening in this Loco. This thing is just going to be lights and motors, right? Nothing as far as alternative lighting. I wasn't going to be squeezing any extra bulbs in here. These two top bulbs going through the ladders are going to also illuminate the side windows and the cockpit windows a little bit, so that should be just fine. We're going to worry about those in a minute. So again, left, right. I love the way that decoder is sitting. One last thing to do before you spend way too much time working on something is check your lighting level. This is a 3 volt 5mm soft white LED. Let's get that back into the picture. There we go. I have selected a 1000 ohm resistor. As my first test, I do want a lot of light because this is, as I say, running through ladder bars, so it's going to dissipate a bit as opposed to if I put them right into the front of the chassis. So I'm just going to touch that and see, are we happy with that light? I think so. That's pretty prototypical. Not too bright, not too white. We are talking about a very old locomotive in real life and in model, so I think that's pretty nice. We're going to go with that. That, as I say, should fit into those exact sockets with those copper pieces removed. So I think that's a suitable bulb and resistor. Again, that's 1000 ohms each. We do not want to connect a 3 volt LED directly to the decoder. As I'd mentioned, we do also want to get rid of these little copper pieces that are just going to get in our way. So let me just get around my post. This isn't being easy. Do I have to be a lefty? No. Let's do this one first. So I'm just going to cut that off because that's just going to get in the way. And we'll spin that around and get the other side. So just going to grab that, give it a little flush cut. That is history. As I'd mentioned, these LEDs are going to snap right into that beautiful little receptor. Just out of curiosity, I'm going to throw this ladder bar up here. Well, it's not really the time. Well, no, it'll fit. That's good. All this stuff is going to be up and out of the way above the ladder bars. Anyway, I'm thinking that's pretty good. The LED does have a lens in the front that's convex. It's a half circle, so it should cast light very nicely there. Oakley dokley. As we like that, I might as well start soldering that one in place. So let me just get this little wire tucked away. It's just a little too much in my face. There we go. Okay, so as in all LEDs, when it comes to the blue wire on a decoder, you're running positive common to both LEDs. Your switched wires, the yellow for the back and the white for the front, are the negatives. So take a look at your LEDs, the long connector. So we have a long lead, that's the positive. That's where we're going to put our blue wire. And the short one is the negative. That's where we're going to put our yellow and white wires. Also, if you look inside the LEDs, just in case you've come to the unfortunate part that you've How are we going to show this? It's not very easy. There's a large wedgy part on the right hand side of the LED that is the cathode, so the negative of the LED, and then there's a smaller section on the left hand side, on this left hand side of my image here. That's the anode, the positive side. So just try to keep the leads, because that does get a little bit ambiguous. The big one is negative, the little one is positive. Inside the LED, it's quite the opposite on the outside of the LED, where the big one is positive and the little one is negative. So keep your polarity straight. Very easy to mess that up. I continually do that because in the LEDs and electronics coming from China, I'm constantly forgetting that the black is the positive and the colored is the negative, which my muscle memory just won't remember that. Alright, I've gone ahead and put in my LEDs with the 1000 ohm resistors. Made things as neat and short and tailored as I can. And now comes the big test, is will it work on the track? Let's give it a shot. Alright, let's have a look and see if this decoder is functioning. Well, I'd say I was happy with that. If you've stuck around this long in the video, I can only assume that you find it mildly entertaining, and that you've found the content informative or interesting. If so, please subscribe to my channel, hit the bell icon, and select all. This is my first video of hopefully many more. Expect content relating to North American, British, and German manufacturers for a start, along with some 3D printing subject matter. Thanks.